This session is about rethinking assembly panel design. It will be presented by Ray Fugitt. Ray has been with us for quite some time. He's been in the industry for 35 plus years. So this is where his specialty is, working with the blueprint and assembly panel design, as well as CAM 350 and the analysis side of things. So without further ado, I'll just pass it over to Ray. Take it away, Ray.
All right, thanks, Mark. Mark just mentioned that, my area of expertise, I was a PCB fabricator, and yes, I'm really familiar with CAM tools. I was not familiar with the design side and creating documentation. But one of the gaps that I had in running a front end in a very large board shop, we were the biggest in the country at one point, is that often I would get these designs and I would be told to panelize them. And the traditional method is coming out of a CAD system, probably with Gerbers, then doing step and repeat on the Gerbers, and then going from there into a mechanical CAD tool. I didn't have any documentation tools. You don't have documentation tools in a fab shop. So I used paint, of all things, to create panel drawings. So just to give you a little background before we get into this presentation, that's where I'm coming from. And I think, as I mentioned in the last seminar, if you're doing this in a CAM tool, it's the wrong place. And hopefully I'll show you why and show you how to do it here in a blueprint. All right. All right, so first of all, I think we need to talk about what exactly, when we say panel, what do we mean? And who designs this particular panel? So first of all, when you talk panels in our industry, you're usually talking two different types of panels. There is the assembly panel, and then there's the fabrication panel. What we're concentrating on here today is the assembly panel. So this is typically created by a contract manufacturer, the assembler in-house, sometimes by the PCB designer, and then in my case, as I previously stated, sometimes it was created by the fabricator. We're going to process the panel as one unit through fabrication, from fabrication through assembly. We will, separate the individual PCBs after the assembly. And it may take some things like scoring, secondary scoring machines or routing machines afterwards to separate the boards. We use the term breakaway tabs. Some people still use that, and some people still break away the boards, but there are other ways of doing it, and the depanelization machines are sold in our industry now. So our goals with an assembly panel, of course, is to minimize the assembly time and cost. That's always a big one. And it reduces the setup and teardown time on the assembly line. And what we want to think about is optimizing the assembly panel for inclusion on the fabrication panel. So look at that again. So I've got 4 boards here. I've got some fingers on these, so I pointed them out. But if you look at the fabrication panel, there's 16 boards there, but those are actually 4 boards in the eyes of a fabricator. And what they're going to deliver to you is those 4 panels back to you or to the assembler. Okay. The designer has very little input onto what the fabricator's panel is going to look like. So, but there are some things we can do to optimize our assembly panel to get more designs on our fabrication panel and thereby reduce our costs. Okay, so let's take a look at that. What should we consider in our assembly panel design? So you want to start early with this because slight changes to things like the board size or even overhanging components, that sort of thing, can affect the final cost. You can always then, manipulate your designs to, again, reduce that size of that assembly panel. And if you involve the PCB fabricator, he can help you optimize that size. Now, What you want to consider, again, is the assembly panel size versus the fab panel size. So small changes to your board size, making it a little bigger, means I can put less on an assembly panel, and less on an assembly panel means less in the fabrication panel. This all affects costs. Okay. So I've got a couple slides here that just kind of show what I'm talking about here. So I have a board here, and this is the board I'm actually going to use for my demo, but it's a 4-up assembly panel that I've created for this board. You can see it over on the right-hand side of actually using a combination of web routes and scoring. And if I just did it with web routes, I might end up with a panel that was 8.1 by 11.1. If I did it with just scoring, as I did over here on the right, I might end up with a panel that's 8 by 11. And why is that important? Look at your fabrication panels. I can only fit 2 of those assembly panels in the fabrication panel on the left side, and the same size fabrication panel on the right side, I can fit it 4 times. Well, as you can imagine, that's greatly going to reduce our costs. So that's why it's important to keep this in mind when you are designing your assembly panel. How many you can get onto it, and therefore what is your finished panel size going to be, and then what are the fabricators' panel sizes. Some other things to consider on your PCB itself. Again, you can create void areas on it, so that you're not putting any components or any useful stuff in the edges where you're going to put things like mill tabs. Don't want to put heavy components at the edges. If you have fingers, you're going to want to rotate those so that they're out. Now, granted, you can do gold various ways, but the cheapest way is to run it down a gold line. And you can do that only if they're pointed towards the external extents of the panel. Okay. Again, as I mentioned, if you have an overhanging component, this is going to reduce how many components you can fit on, or how many boards you can fit on your panel. So again, just something to keep in mind if you have a connector, as we do here, at the panel edge, or the board edge. Different ways of doing the panel. Web routes with mill tabs. Web route is just that. It's slot that's cut by a mill tool. It's usually around the perimeter of the PCB. Mill tabs are added to give rigidity and connect it to the panel. And then later on, those are broken out. Now, there's various types of mill tabs. And in our tool, we do give you the ability to create pretty much any shape of a mill tab. We will also combine panels. We can do panels combined of mill tabs and score lines, so that you can, again, reduce the size, because if you're only putting things up against each other, or maybe 5-10 mils between the boards, obviously you can get more boards on your panel. Another term we should talk about is an assembly rail, or it's the frame of our panel. And as you can see, this panel here is all scored with rails off to the side, and they're just at the top and bottom. They're not on the right and left, and often that's not necessary. They do provide stability, and typically you add tooling holes, fiducials, and in a lot of cases you add extraneous copper to those too, for etching and warpage reasons. Tooling holes are typically added. That's what we're going to mount this thing to on the milling machine or the D-panel machine. And then fiducials, of course, are for your vision equipment for doing the actual assembly. We also support some other things, so you should keep these in mind. Flip panel, if you have a 6-layer, you could have a top row of layer 1 and, or as I do here, a bottom row of layer 6, and then 5 and 2, 3 and 4, 4 and 3, and so forth. So what this allows you to do is, again, you should be able to reduce the cost of assembly, because basically you run it down the line, you flip it over, and then you run it down the line again. There's no secondary setup in assembly. Another thing to keep in mind is X-outs, and this is very important, and your fabricator probably brings this up to you, but if you do not allow X-outs on your assembly panel, basically X-outs says that one board can be bad or multiple boards can be bad in your panel, then the panel becomes the board. So instead of paying for a 4x4 board that's, you know, 4 up, you're now paying it for a 16x16 board, which has to be 100% correct or it gets scrapped. So you're going to pay a lot more money if you do not allow X-outs in your panels. So what it provides is a PCB fabricator, and this is an area of contention, and this does come up a lot. And when we've gone back to people and they've queried their fabricator, it always comes up the same. And again, I have all that experience and a lot of contacts in fabrication. But the point of all this is, if I deliver stepped up Gerber or stepped up ODB to my fabricator, guess what he does? He deletes it, goes back to the 1-up, tools the 1-up, and then panelizes it to match your original panel. The reason for that is the document is the key. Everything revolves around the document. So we're going to match what the document says, and that's what all fabricators do. So if you're doing the traditional method of going from a CAD tool to a CAM tool and then off to a mechanical tool to create a document, a lot of that can be wasted time, and because again, the fabricator may just throw away parts. Maybe they'll use some of it, but parts of that panel that you've created. What he really needs is the document and a 1-up. Okay, and that is our panel drawing with any dimensioning, notes, drill chart, mill tab descriptions, details, so forth. And then what do you provide to the PCB assembler? And we'll talk a little bit of this at the end. One of the things is Centroid information. And we can do it in panel form, but another thing we can do in Blueprint is we can do it off of variants, and we can also do process steps. So you can choose all of that when creating a Centroid report. Okay. A lot of our contract manufacturer customers, sometimes they'll just get Gerbers and a component list. We highly encourage trying to use one of the more intelligent formats when delivering that information. And, you can limit the intelligence so that you're not giving away, things. But most of the intelligent formats, and particularly IPC 2581, allow you to dumb down the data on output so that you're not, as they say, giving away the farm as you give this off. All right, so there's my, again, my panel design in Blueprint, actually an older version of Blueprint, but let's take a look at it in the current version of Blueprint. Okay. Okay, so here is my document set. There's some other parts to this that I'll show you at the end, but I just want to start right off with the demo and make sure we get through this on how we're going to create our panel here in Blueprint. Okay, I'm going to go around the screen just a little bit to show you some things that we've created in advance. One of them is the mill tab detail. Basically, when you go to the panel drawing palette here, you'll see mill tab detail, and it's got the various types there that you can choose, and it will automatically create the detail for you. So I have this placed on the sheet before I even load data. And I think that's critical to realize. I have a drill chart placed before I even load data. I have a panel placed that I've already placed my fiducials and tooling holes. These are all part of my standard template for my document set. So whether I make the panel bigger or the panel smaller, these are already placed, and I don't have to redo that each time I'm getting ready to create a new panel. Okay, so just keep that in mind. A lot of this can be templated and done in advance, so you don't have to do it each time. So when we're ready to start working on our panel, what we do is we format it. And this is where we decide how many boards we're going to put on it and rotations if we decide to do that, flip panels if we decide to do that. This is also where I've added the pinning holes. And notice as I go through these, I used a relative mode, and it was relative to the panel edge. That's how I was able to put these down before I even started the panel. Okay, same idea with fiducials. Okay, so they're placed, locations are placed, and what I'll do, of course, is I will provide a note that says put a fiducial here. Since I'm not providing the stepped up data, I need to give a note to the fabricator to do this. Now, I have heard comments in my time in working with blueprint and documentation tools. Well, they did it wrong one time, so that's why we provide the stepped up data. Well, if they did it wrong, I don't know how you can trust them for anything else. So my answer to that is always fire the fabricator if they're constantly doing it wrong. They have a good document. They have the one-up Gerber. That's all they need to do a panel. I know I've done it for many years myself. Okay. Some other things that you can do here in the setup is you can round the corners of your panel, and then you can put that note that you see often on panel drawings, no sharp edges. You can even do things like image letters and show this, and if I rotate some of these, it'll show those in my panel as well. But what I'm going to do now is go back and just do some modifications to this setup, and then we're going to continue on with our panel. All right, so I'm going to go to a spreadsheet mode. I am going to tell the software to keep the AutoCalc settings, but what I'm going to do is rotate boards 1 and 2 180 degrees. Okay, and is able to keep them in place when I do that. And a nice thing here, and I didn't have this in other tools I've used over the years, is I can now jump back to AutoCalc if I wanted to, and I'm actually going to put these boards up against each other. So you can do a combination of spreadsheet and AutoCalc just by jumping back and forth between the two. Okay. Now I'll mention a couple other things from the screen just because I'm here. I have format all my boards. This is just like if you're formatting an individual board in Blueprint, you have access to all the data. You can show anything you want. And I like to lock the boards in the panel so that I don't accidentally move them when I'm doing the actual web routes and things. So there's our good start to our panel. And now what we're going to do is we're going to edit the panel. Now, when you edit the panel, we do use this color scheme here, which you can modify. And one of the things I like to do is turn on my top and bottom side components. And this allows me to see, as I'm placing things like mill tabs and so forth, if I am placing a mill tab over a component. Okay, so it's just for our design stage. This is not going to show on our finished document unless we wanted to. We could always turn it on in that as well. But this just gives us an idea for when we're placing mill tabs and score lines and web routes. Now, what I've decided here on this particular example, and I have other examples which I'll show you, but on this particular one, I'm just going to add a web route. And there is a default web route size, and you can modify it on the fly, or you can modify it in your options so that it always comes up a particular size. So I'm using a 100 mil web route here. Notice it overlaps the other boards, but the software is going to be smart enough to get rid of that once we place our score lines. I'm not going to do a mill tab on this one, but I'll show you one in a second that has a mill tab. All right, so again, I'm going to grab this. I'm just going to say apply this to all my images, and it copies them out to all my images. Zoom back out a little bit. And now what I'm going to do is I'm actually going to place some score lines down here. So I'm going to place a vertical score line. Oops, I grabbed the wrong thing. I did. There we go. A vertical score line. And then I'm just going to zoom in because I want that to make sure it snaps to the board edge. And then once I do that, I'm going to zoom out a little bit. It's easier to drag if you're zoomed out. And you notice how it's going from side to side there. Well, I don't really want that. So one of the things I should be able to do is turn on the orthogonal snap so that it locks it to a 90-degree angle. Okay. So again, zoom out a little bit here. And I'm just going to drag this up to the top of the panel and then down to the bottom of the panel. Okay, and then we're just going to do that 3 more times, and all I really need to do is, and I could just copy and paste, you know, right-click on it, copy, paste, and then place them. There's even a step and repeat option here, so I'm going to use that. Go back over here, and I'm going to do a step and repeat, and my offset is the size of my board since I put these up against each other, and hopefully I remember this. It's on my notes, which is on my desk, which is not here. And I'll say okay. And again, you can see where it added those score lines there in the edges. And then I'm just going to place a score line horizontally here in the middle. Okay. Again, make sure that that snaps. And then drag it off to the edge. You could actually drag it off the edge if you wanted to. It's not really going to affect anything. Okay. So now I've placed score lines and web routes. In this particular one, I'm not placing a mill tab. If I wanted to place a mill tab, I could just drag and drop it and place it down here, and then I could adjust it with the coordinates set up right here as to the location I want it. Once I've done this, all I really need to do is merge my web routes, and any areas that would drop out, drop out. Looks like I didn't get the score line exactly on the edge there, and that's why that area didn't drop out. But that is the idea, that you can merge. Again, I need to zoom in here. Okay, now I got it. So again, just operator error there, but if you see it, it doesn't do it exactly, then you know exactly what occurred, that you did not get it snapped to the edge there. Okay. And now if I merge them again, it should be okay. Okay. All right, so there is my panel done completely with score lines this time. And if I click outside and say okay, as you can see, we have our really nice panel here done with web routes and score lines. The reason I didn't add a mill tab is it probably doesn't need one, and I don't want it on my art, okay? And just in my personal preference at this point. Because the score lines, you know, are still adding enough rigidity to the board that I don't need an additional mill tab down here. Okay, another thing you can do is you can add a score detail. I think that's a little big, yeah, and place that. These parameters can be defaulted and set up in advance, again, in your template. They come from the milling manager, or excuse me, the fabrication manager. The PCB attributes, you can set up your depth and everything in advance. Okay, if you have another detail that you use that's not part of Blueprint, you can certainly just, you know, if it's DXF, BMP, JPEG, copy it, paste it, make it part of our gallery, just the standard Blueprint things. One more thing here on this. I am in this particular drill chart showing all the drills. Often you have a one-up, and it already has the board image drill. So all you really want to show is the ones that you've added here. And really all I've added is the tooling holes, okay? So I would add some notes and I would add some dimensions and basically be done with my panel. And this is why I say, if you're doing this by going through several tools, it often is a waste of time, and especially if the fabricator is going to throw away parts of what you had to go through to create it. Some other things I should point out here. I showed you that while I was in that edit mode, that I turned on the components so I could see that when I'm placing the mill tabs and web routes and score lines. We actually have a tool for doing that for you, and it's in the milling manager, milling checks. You can actually set up so that when you are placing components or when you're placing these items, you can do a DRC to components, to copper, to drill. You can do keep ins, keep outs. All of these things can be set up so that maybe you're not the one creating the panel, but you want to keep it out of a certain area, you can set that up in advance. Here's where you can create the various types of mill tabs. You can see some of the ones we've created. Once you create one, you save it to the gallery. And if I go over here and just click on mill tab, you'll see some of the ones that I've created. Okay. And we, again, the one I prefer is this multi-perforation, which is what my mill tab detail is up there. Now, if I had done this with just score lines, of course, I would probably get rid of the mill tab detail. Okay. And again, add some notes, add some dimensions, and I'm done. All right. So that's, again, the process. I want to show you a couple other things, and we'll go through those. So let me fit this sheet again, and I'm just going to move on to the next sheet and then show you an example of one I created. This one has mill tabs at the top and bottom and web routes. The entire panel is done with web routes and mill tabs, and we didn't score this one. And you can see where I have placed all the dimensions and everything that goes along that you need. And then I placed a call out here on my fiducials and my tooling holes. This time I didn't do the drill chart. I might just, a lot of people will do this. They don't want a drill chart. They just want the a call out that basically says do a 125 hole several times. And I'll do the same thing with the fiducial notes. Okay. So I would probably, on this particular one, just delete the drill chart. So now I've got my mill tab detail, my mill tabs, their locations, any call outs, notes, and my dimensions are already placed. Again, another way of doing a particular panel. Okay, let's go to the next one. Okay, this one I did is, actually this one's the same as the first one, but I've just placed the dimensions on it. So in this case, you can see that I've placed dimensioning, and I've used some of the advanced tools that we have. You notice that there's dimensioning tools inside of the panel palette. And what those allow you to do is things like this. They recognize that, that there's additional things in line. So whether it be a tooling hole or a fiducial, when I click on these elements there, I can go ahead and show totals for any of these items when I place the dimensions. Okay, so just again, another way to do it. But these are several ways of doing your mill tabs and score lines and combining those or using them individually to create your panel. And as an aside here, just again, talking about my past experience, just creating one of these in my old fab shop probably took me 4 hours. And as you saw me do it, I did it in 10 minutes on the first one, and that's with explaining it as I'm doing it. Now, granted, you can have some things that'll throw you curves. We got a radius here, and it dealt with that just fine. And actually, you can move your mill tab along your radius. That's not an issue. But you can also add segments. Some people like that true, let me go back to the previous one here. They like that true rail on the side. So what I would do is just add a route segment that takes this off to the edge. Okay, right now I have my tooling hole placed there, and it would just do the true rail. And if I don't want them on the sides, I can just delete them off the sides. So again, we've tried to give you all the tools you need to really quickly create this panel drawing. We're not trying to be cam operators, my old job, where I had to create a mill program. Then I had to insert drills into that mill program, and that's what becomes a mill tab. A mill tab doesn't exist for Fabricator. It's basically just the location where the web route ends, and then they put drills in there. So you have to know how to do some NC programming in order to do that on the fab side. And what's happened is we've made you the designer, an NC programmer, because that's the only tool you had to do it. And if you did it in CAM 350, trying to get a document from the result was very difficult. A lot of people end up in AutoCAD trying to do that. All right, I'm going to move on here just because of time. But hopefully this has given you a good overview of how we can create that panel in Blueprint. Now, one of the things I mentioned before, and I'm just going to put these continuous here and scroll down a little bit. If you were in any of the presentations yesterday, Joe Clark did one on working with process steps. These are those color-coded charts that you create, tell you what gets assembled in what step, and variants. So we've got variants and process steps here, okay? The reason I point that out is that I can actually do a Centroid report on this panel, first of all, and that would be just simple as export a coordinate list, all right? And let's just throw it out here. And if I don't have variants or process steps, I just write out, you know, the panel. I put the Centroid report in panel form, so it shows all the boards in the panel. But here, I can actually choose a variant, and I can choose process steps and create a Centroid report for everything or bits and pieces of this. So that's why it's important. So this time I'm just going to do it all process steps, and you know, ask you how you want your Centroid created. Do you want components from both sides or just one side? Some people split up their Centroid top and bottom. All of this can be done whether you have variants or process steps. You can export your panelized Centroid report, and then you pick the panel. So I have 3 different panels here, and maybe you're trying 3 different panels. So you can pick the panel that you want to use with all that other stuff in mind, and basically just write out a CSV file here. I won't do that, but I just wanted to point out that basically you can create a Centroid report, not only for your one-up board, but for a panelized board, and then you can take into account both process steps and assembly variants in doing that. Okay, I think that's all I want to show in the demo right now. We would just simply export this to PDF, of course, and that's what we would send along with the one-up Gerbers to the fabricator. Okay, is my moderator there? Okay. I seem to have lost my moderator.
No, I'm here, Ray. Sorry, I didn't realize you ended. Sorry.
Oh, okay. Yeah. Sorry.
So we have.
Are there any questions? Yep.
Yes, we
go
do.
ahead.
Assembly panels are an additional option, correct? Panel design, additional blueprint option.
Yes, they are an option in Blueprint. You don't have to have them. You can kind of manually create panels in Blueprint, but this automated way we did it is an option, and it is in our highest end bundle of Blueprint.
Right. Very good. Another question. Can I export mill and drill data from the created panel?
And this goes back to what I talked about originally, and the answer is no. We may do this at some point. We've thrown this around since we had the panel tools, whether we should do this or not. You know, again, going by experience, most fabricators will try to use some of it if they can, but a lot of times, I know especially in my case, we threw it all away and recreated it for the most part. We may do that at some point. We may actually, we're not really creating a route program when we create this. This is just graphics. And that's why we've made it so easy to do as opposed to going through a CAM tool. We know we can create the graphics real easily. If we had to create a mill program and then we had to create, the drills, call them mill tabs, then we have to kind of rewrite Blueprint to do that. So Blueprint is a documentation tool. Our goal here is to create the document.
Okay, I don't see any more questions. If anybody has a question, now would be a good time to.
Yeah, and I'll go a little bit further with that. I don't want to cut the user short on that. And we have gotten feedback, especially, and I know this user's in Europe, we hear more about people wanting the stepped up data in Europe. And quite frankly, the only response we get here in the US about that is stencil makers want the data right away. So I know in my previous job, as soon as I did the step and repeat, I would output a stepped up stencil or stepped up paste layer and send that to the stencil maker from the fab shop. And that's how they knew the step and repeat. Because, you know, right or wrong, we're worried about somebody in the process getting it wrong. You got a good document, though. Remember, we imported the board into Blueprint. So we have the real dimensions of the board. I don't know how many times I looked at a fab drawing, a panel drawing, and it was wrong because it wasn't based off of real data. They just basically output it out of, probably DXF out of their CAD tool and then took it into AutoCAD. And you know what, rounding errors, leaving off the fourth decimal place, all of these things can cause problems. But we're using the actual data to create this panel. So that's why we feel that the panel drawing is the priority here.
Okay, I don't see any other questions, Ray, so I guess we'll bring it to a close. Thank you so much.
All right. All right. Thanks, everybody, for your time today. I'll just throw it out there. This will, Mark has mentioned this before. We will have the recorded versions of this, as well as we do have that YouTube site that already shows how to do this on it as well.